الآن يمكنكم المشاركة في مبادرة الأيام الرقمية تحت شعار انطلق بقوة مع جوجل، والتي يتناول فيها خبراء جوجل عناوين جديدة أسبوعيا مثل السحابيات، مهارات من جوجل، أندرويد، فلتر، ذكاء الآلة، فايربيس، ديزاين ثينكينج، مقسمة إلى دورات وورشات عمل يومية بالإضافة إلى مسابقات أسبوعية. شاهد الأيام الرقمية مباشرة على اليوتيوب وشارك رأيك وأسئلتك مع خبراء جوجل، واحصل على شهادة حضور في كل محاضرة تشترك فيها. هذا وأكثر من الأحد إلى الخميس ابتداء من الساعة 9 بتوقيت دبي عبر الرابط المبين youtube.com/gdgmena.
السلام عليكم ورحمة الله تعالى وبركاته. أهلا بكم في حلقة جديدة من MENA Digital Days. معكم عليان عبد النور، GDG تيزي وزو الجزائر. واليوم بإذن الله سنتكلم عن كلاود ران، لكن هذه المرة ستكون في عدة حلقات عن كلاود ران لأننا سنتحدث عن الأساسيات البيزكس. السيشن ستكون بالإنجليزي in English. إذا كانت لديكم أي أسئلة يمكنكم طرحها وسنجيب بإذن الله. Hello everyone, Zulflowen. I'm Aliane Abdenour, GDGTZ Zoo, Algeria. I will be with you within an hour where we are going to talk about Cloud Run, and this session it will be in a lot of sessions because I split them into basics and intermediate and advanced topics, where today we are going to talk about the basics, which are the containers and virtual machine, because the objective is that you can understand the basics before you decide what to do, because always learn to ask why, and then the how, it's easy. It's just a matter of commands. But the most important for me, at least, is that you understand how you are going to think and why you are going to opt for this technology, because there are other technologies in GCP. So why you are going to use Cloud Run, why you are going to use App Engine, why you are going to use Cloud Engine. So before we begin, before we start any kind of service here, I need you to understand the basics of a container and the basics of a virtual machine. And of course, if you have any questions, please ask them. I will answer later. Okay, so before we begin, the difference between a virtual machine and a container is that in virtual machine, let me start drawing because I will draw a lot today. So in a virtual machine, what we are doing, we are running first our infrastructure, which is, for example, Windows, or which is the hardware itself. And then we install on it an operating system. And then we write an hypervisor, for example, VMware, VirtualBox, Xen, or ESXi. And then we run other virtual machine. And at last, we run our application. And as you can see, the problem about this architecture is that to run a simple application here, I need a lot of resources, which is not a good idea, but it has its advantages. So what we did, we tried another solution, which is using a container. A container is not only a Docker. We will see that in a few minutes. So what we do, we have our operating system and hardware, and then we run our container engine, which is, for example, Docker, and then we run our containerized application. So I will go now for the details. So what I do, I will redraw this thing, but in easier way. So let me run this. So I don't need this anymore. And let's run this application. So, okay, let's switch here. Okay, so the main idea is that if I have, for example, let's explain first the virtual machine. So our virtual machine In the past, if we need to host an application, I need a server, and the server costs a lot of money. And then in the server, I need to install an operating system. And on top of the operating system, I need my application. So the problem is that if I need to scale, that means that I need a lot of machines that I have to buy. The problem with this solution is that it costs a lot of money. So what we did, we tried a new concept. The concept is easy. Here is the new concept. So in the new concept is that I'm going to run one single machine, and then I will use an hypervisor to run virtual machine. The good thing about this story is that I don't need other machines, hardware. I only need, for example, one single hardware, and then I install, for example, VMware. And inside VMware, I'm going to run virtual machines. But the drawback about this solution is that to run a virtual machine, I need another operating system, which means that with each virtual machine, I need an operating system. And that costs my resources, for example, the RAM, because before I load my application, I need to load first the RAM, and then the operating system, and then I run my application, which costs a lot. And the second problem is that since it runs a lot of resources, to start this virtual machine, I need time. Of course, this is not a big deal, but I need some time so this machine can be what we call provisioned. So this is the virtual machine. So what we did the second solution. The second solution is that I have my machine with operating system, and then instead of having a new operating system here, I don't use an operating system. I go directly to the application, which means that I use less resources. But here I need a lot of resources. And then there are other solutions that we will go later. But right now you need to understand this big difference between containers and virtual machine. In virtual machine, I need to rely on another operating system. But in containers, I am relying on the same operating system. So when I say operating system, I don't mean operating system. I mean what we call a kernel. So the difference between containers and virtual machine is how many kernels I'm going to use. So in virtual machine, I'm using as many kernels as virtual machines. But in containers, I'm going to share the same kernel. So this is the old way we used to use containers. And in the past, the containers, there was no Docker. In the past, it was what we call LXC for Linux container. So when I say Linux container, it's clear that I say the word Linux. That means that if I have here Windows, I can run Linux in virtual machine. But in containers, if I have Windows and I want to run Linux, I can't. I need a thin wrapper. And this thin wrapper, we will discuss about it. So let's make a demonstration, a simple demonstration. So to do this, I'm going to use directly Hyper-V. Hyper-V is included with Windows 10 Pro, and that's fine. So I did include the Hyper-V, the icon of Hyper-V directly with VirtualBox to tell you that if you use Hyper-V, you will have issues with VirtualBox. So you need to either disable Hyper-V because it's a service that you can enable or disable on Windows, or directly use the Hyper-V, and that's fine. So disable Hyper-V, you can use VirtualBox. If you enable Hyper-V, you will have problem with VirtualBox. So right now I'm running Windows 10. So I will run Ubuntu, which is Linux. So I'm going to run it on top of Windows. That means that I need a virtual machine. So directly here, I will connect. And as you can see, it's faster than a physical machine. That's the first advantage about a virtual machine. They are really fast compared to a hardware. So let me connect. And that's it. I have now a machine, a Linux machine inside the window. And as you can see, it's just a window. It's like a Word or Excel or a Google Chrome. I'm running a window, and inside it, there is a machine. And inside this virtual machine, I have a fully working Linux. So, and it's Ubuntu. I hope it's visible. Okay, so this is a virtual machine. So a virtual machine is a machine that needs an operating system. So here I can run my application. For example, I have a Python application. But if I want to run a container, here I need a Docker. So the command that we always need is Docker. So it's just Docker. We need to install Docker, of course, and then do Docker run. So there are two commands. We have Docker run and Docker pull. But when we use Docker run, we are in reality, what happens, let me draw another thing. So let me delete this. So when we run Docker run, oops, sorry. No, okay. So when we run Docker run, what happens? It checks about if I have a Docker image. So an image, it's like a box that contains everything. Now, why do we need to do that? So let me give you a simple history about the problem that we face as developers. So the problem here, imagine I developed, I think that maybe one time you have already installed WAMP. The problem with WAMP is that people always say, I need the DLL on Windows. There are always a missing DLL. So the problem is that I need to find a way how to include everything inside the box and to give it to you. So in this way, I can directly create a virtual machine and give it to you. But the problem is that a virtual machine, so you have, for example, 2 GB of RAM, and you want to run a WAMP. Why do I bother you with another operating system so you can run WAMP? So I have two solutions. I give you everything in a virtual machine, or I give you a Docker image. The good news with Docker image that it's self-contained. Everything is in a box with dependencies, all of that, and it will work with less memory. In the past, how we were doing this, if you know Java, then you already know what a JVM. JVM is a Java virtual machine. When Java was a trend, people were saying that's a portable code. What does it mean that I can run Java code in Windows or in Linux? Why? Because if I have Windows here and my code is here, this is not Windows that he is going to run my code. This is the JVM, which means that I can change my Windows with the Linux and it will work. I will not bother myself with the operating system. As a Python coder, we have what we call virtual environment. So why in Python we have virtual environment is that if I run here virtual env, it asks me which Python do you want to use. You need to understand one thing between Windows and Linux. In Windows, that's fine. I install Windows, I bring Python, I install it. In Linux, that's not the case, because in Linux, there are many applications, system applications that depend on Python. So if I run a dependency, I can break the system. So that's why I need to run my Python code in a closed environment. But the problem with virtual env, it's only, so let me, I have a Linux, and then I installed Python, and then I have my application. The problem with this solution is that this Python, it can be shared with some Linux commands, Linux applications. So if I break this Python, I can break the whole system. So what I do, instead of running my app here, I install a virtual environment, and then I install my application. The good news is that my application is contained. That's why we call it containers. But the bad news is that I only use Python. So if I need other dependencies, I cannot use virtual environment. And the same goes with JVM. JVM, I will only run my application, but if I need other dependencies, for example, DLLs or whatever, then I cannot rely only on JVM, because DLL are only for Windows, and on Linux they are called SO. So DLL versus SO. By the way, I'm going to talk generally, yeah? So don't worry. If you have any questions, and this session, there will be other sessions about only Cloud Run. So this session, the first session, I will try to talk more about operating system than the Cloud Run itself. So virtual environment, we were using it between Python developers. JVM, that's a way how to port our application between Windows and Linux. So virtual machine came. What happens is that with virtual machine, I can contain everything, including my app from Python, including my app from Java, and make it portable because it will be only one single file, which is the virtual machine file. For example, VDI for virtual box, and all other virtual machine we already talked about. So the problem with this is that if I have a virtual machine, for example, VDI, let's say that's a file, to run it, I need VirtualBox. And VirtualBox, to make it run, it needs another operating system. For example, I developed it on Linux, it needs all of this. So those are the layers. If I'm upper, I only need virtual environment or JVM. If I'm down, then here I ask myself, do I need a VirtualBox, a virtual machine, or do I need a Docker? To answer this crucial question, let's talk about security. So if I come back here, sorry, if I come back to this drawing, what I'm going to see something. As I told you that when we have a Docker application, let me use the red because here it's a matter of security, it's dangerous. So when we have Docker, the problem that is this application, this container, if I have a security issue, I can do what we call an escape. I can escape from this container and affect the other container. But in virtual machine, we cannot escape easily. Why we cannot escape? Because we have the kernel. The kernel is what is the heart of the operating system. Linux kernel, for example, when we say Linux, there is a difference between Ubuntu and Linux. Ubuntu uses the Linux kernel. So Linux, this is not an operating system. This is a kernel. But when we say Windows kernel, that's fine. That's a Windows kernel, and then there is Windows 10, and then there is Windows Server, and so on. So the kernel, this is the one who is responsible about managing the stuff. How the kernel works, and of course, the session, it will be a little bit deeper. I show you the concept of the kernel. In the kernel, we have what we call the rings. So right now I'm using Google Chrome and I am explaining you stuff using some drawing tools. What I'm doing right now, I'm using what we call a user space. I'm here. So this layer, this is reserved for the user. That means that I can run application, I can run Google Chrome, because they don't interfere with my operating system. And the kernel, this is what the operating system considers important. So if I crash Google Chrome, for example, only Google Chrome crashes. But if I crash something related to the kernel, all the operating system will reboot. That's the difference. So this is the user space and this is the kernel space. Now, the user space, for example, Google Chrome, of course, it needs to talk to our operating system. So to talk with the user space, with the kernel space, we need what we call the syscalls. So a syscall is how I jump from here to here. And by the way, as you can see, there are 4 layers, but in modern operating system, there is only ring 0 and there is the ring 3. There is no ring 2 and ring 1. So Windows and Linux, they use 2 layers. So what is a syscall? The better way to explain you what is a syscall is using Linux, of course. So let me go to Ubuntu and run a command. So let me switch here. Where is my hypervisor? And where is, yeah, he is hiding here. So if I do, for example, echo, I think this is not visible. So let me, so where is it? 24. I think 13 will be good. So it will be visible for everyone. Okay, I think like this it's visible. So if I do echo hello, echo hello, what happens? That's simple message that I tell him, print me a hello, it prints me a hello. But this is not as easy as it is in operating system, because what I called here, I called some std in and I got some std out. So std in, this is what I typed with a keyboard, and the std out, this is what I am seeing right now. So of course that depends on drivers, that depends on the screen, if I'm using the screen or a data show and so on. And in reality, this is what I am running as a user space, but in a kernel space, I will use a command that is called strace, and I type my command, echo hello. Strace for stack trace. So here is a weird code where there are weird numbers. Those weird numbers are the RAM address. So I am not allowed to access those addresses. Only the operating system is allowed to access to those addresses. What I did, I wrote echo, but in the kernel space, there is no echo. The syscall, this is called write. So let me come here. So what I did, let me redraw the 2 rings. Yeah, that's weird. So here I'm in the kernel, and here I'm where I typed echo hello. So what happened here, it went to the kernel space, and here they execute write. So write is called a syscall. Now, why I am breaking your nerves with syscalls? This is because to make you understand the big difference between a container and a virtual machine. So if I come back to the virtual machine, as you can see here, the syscalls are shared. Of course, they are isolated. Everyone can go here, but they are all sharing the same kernel. But here, everyone has its own kernel, which means that I don't get to the other virtual machine. Now, how is those syscalls getting separated. And this is what we call the C groups. So yeah, don't worry. So I will write the word C groups. Can you please share the links? So in case you will need them, I shared with you links where you can document this. Today, of course, it's a live stream. If you have questions, you can ask them. You can put the comments, and we will have another session if you have other questions and so on. So right now, we are using what is called the C groups. So the C groups, let me go back to Linux because I prefer explaining everything because it's called Linux container after all. So the C groups, this is using the command which is called the lsns is for list namespaces. So the C groups, this is just a part of the namespace. So if I do man name spaces, some namespaces, this is what allows us to separate everything. How am I am going to separate? I'm using a lot of separations. So we are using a C group that I just said. So what is the C group? This is something like, okay, I need this container to only use 1 giga of RAM. I don't want him to go beyond 1 giga of RAM. This is the way how I am going to reserve resources. So resources, they are done using the C group. The IPC, this is inter-process communication, which means that I'm going to isolate the process here to not allow him to communicate with this process until I authorize him. The network, I'm isolating this with an address that it cannot come here. The mount, I'm isolating the file system to consider himself that this is the root. So for people who knows what is, so let me explain this better. So so if I come here, there is a big difference between Windows and Linux. So in Windows, everyone knows what is the C, and we have the D. Those are the partitions. In Linux, everything is under the root. This is the root. And then we call, for example, SDA, and then, for example, dev SDA2. And then the root is this, which means that our disk is considered the root. Not like in, for example, in Windows, this is an operating system. So this is equivalent to this. And the D, for example, this is equivalent to this. So my disk, the whole disk, this is the root. So if I format the root, that means that I will lose everything. And this is the mount namespace. So the mount namespace allows me to think the application that it's running on its own hard disk. The PID, this is for process ID, which means that if I run a container, it will have a different ID than the one that I'm running on another container. The user, of course, it will have their own users, and the UTS, this is not about time. This is like weird. I don't know why they name it like this. The UTS, this is for host names, for example, local host, which means that the local host here, this is not the same as local host here, 127.0.0.1. So local hosts are different from here and here and here. And this is the UT, where it is here? Yeah, the UTS namespace. So I am separating my containers on Linux using namespace, but you will always and a lot hear about C groups, because the C groups are the one who are responsible on isolating the resources. I give him 1 giga RAM and so on. So to explain you this directly, let me run Ubuntu again. And I quit here. So as you can see, those are the namespaces. cgroup, PYD, and so on. So let me run Docker. So I think that I have already this here, so I don't need that. Yeah. So what I did, let me give you an overview. So right now, as you can see, I changed it to the root. Am I on the root of the system? No, I am in the root of the container. This container, so if I do cat etc OS release, I am running right now on Rocky Linux. Rocky Linux, by the way, this is a replacement for CentOS, because as you can know, I don't know if you know it, CentOS now, the Red Hat changed how CentOS works. So now the community needs another operating system as stable as CentOS. So there are many alternatives. You can use Rocky Linux. Why I'm using Rocky Linux? Because it's already available on Google Compute Engine. So Rocky Linux, this is a Red Hat alternative. And as you can see, I am running two operating systems, etc. So sorry, cat etc OS release. I am running Ubuntu and Rocky Linux on the same machine. And as you can see, look how much time it takes to run the container. Instant. It's like 2 seconds or 3 seconds. Now, let me explain you the command. So the command Docker is the command that we know. But you need to understand, Docker is not Docker. Yeah, that's weird. I will explain this in 5 minutes. Don't worry. Run, I'm asking him to run. So if I rerun this command and tell him I want Docker run IT Ubuntu, it will tell me, do you have Ubuntu locally? I don't have this. So what he does, he goes to internet and downloads the image. I don't need to download the image. Now, let me show you something. So if I do this, if you see, I don't have CentOS 2, but there is still the image. Don't worry. So look at the size. We have 75 mega, but Ubuntu, it has 28 mega. The difference is that since I'm already on Ubuntu, this is like an upper layer. It doesn't mean a lot of dependencies, but since I am running a Debian system, which is Ubuntu, it is different from CentOS, which is a Red Hat system, but they share the same kernel. So that's why I need more megas. So let me rerun the Rocket Linux. And here I'm asking him IT, which means interactive, and I need you. Let me do something. So if I rerun this without the IT, it will run and exit. Why it exits? Because I didn't ask him for something like interactive. So this is useful if I do echo hello. So echo hello here, it didn't got executed with my Ubuntu. It got executed using the Rocky Linux. So what I am asking him now, I don't want to run it and exit. I want to make it interactive and reserve a TTY. TTY, this is this window. So if I hit it, now I am inside the container. So how much memory do I am using? So to do this, don't use the command free. So free, it is used to know how much RAM do I have. And as you can see, I have 8 giga of RAM, which is false. Because why? When I did this command, I asked for 2 giga of RAM. And this is the namespace we just saw. I'm reserving 2 giga of RAM, the C groups to be exact. Now, to know how exactly do I have in memory, I need to use Docker stats. And as you can see, I am in another window. I'm not inside this. Why? Because here I'm inside Red Hat. I'm inside Rocket Linux. But here I'm inside Ubuntu. So if I do Docker stats, as you can see, I'm reserving 2 giga. So I ask him, don't go beyond 2 giga. And if I quit, and here, if I quit again, and I ask him, I want this time 4 giga of RAM. And I use this command, and as you can see, the Docker cannot go beyond 4 giga of RAM. And the good thing now with containers is that I can do this, 10 mega. I want my container to have only 10 mega. Now, why do I need something that has 10 mega? Because Docker is made for microservices. Don't try to run something really complicated inside a container. And this is what we call a monolithic versus microservices. So a monolithic and microservice, I hope I didn't broke your nerves. So microservice and the monolithic came from an old naming, which is the kernel, of course. So in the kernel, in the past, there were two types. Of course, there are many types, but it is important here. So we have the microkernel, and then we have the monolithic kernel. So the monolithic kernel, everything is inside the kernel. But the microkernel, we try to put only the most important stuff inside the kernel space. Everything, and then we separate to avoid crashes. So you can check about microkernel and monolithic kernel outside this code. So the developers try to make the same logic. So we have an application. So we try to split it in a lot of codes. Instead of having one single code, we'll have a lot of codes. Now, why do I need this? Let's have this example. By the way, I'm repeating the same example than the Thursday session because I got issues with the connection, and alhamdulillah, until now, everything works. So I will re-explain this example. I'm here. What I do, I access to this application. So what happens is that in the past, there is, I think this is too thick. In the past, everything here, we were writing it in a single file. For example, I call it myapplication.php or myapplication.py or whatever. The problem is that it didn't scale well. Why? Because this person, for example, he only needs to add an address. Why do I load the code about updating address and deleting address and sorry. Why do I need this code about listing address? So let me delete everything again. Let me redraw something better. So I am here, he's in hurry, and I want to access this application. So in the past, I need everything in a single file. The problem with this solution is that if I have a lot of people and only one person wants to add the address, the problem is that those two people, they can have issues, resources issues with updating or deleting or listing the address because maybe he took all the resources. So what I do, I split the traffic. I tell him, okay, do you want only to add address? Go here. Those people, they want to delete the address or update the address, that's fine. Just redirect them then. And in our infrastructure vision, that means that if adding address needs a lot of resources, I will run here. I will run a Docker. So let me, I will run a Docker with, for example, adding the address. I will name it adding the address, and then I run the container with better resources. For example, everyone is asking to add address, and I see that adding address needs a lot of resources. That's fine. I put it in 4 giga of RAM. But listing the address, for example, it doesn't need a lot of RAM. That means that I will only reserve it with 1 giga. I am splitting the traffic and I'm splitting the resources. And I'm doing this using containers. So containers is what we call the immutable infrastructure. Before I talk about immutable infrastructure, I need you to understand this concept. So containers are here to split the work. So the best thing about this philosophy is that if I have a team, several teams in my enterprise, I take the team that is responsible about adding address. I don't bother the other teams. I have a bug here, that's fine. I will only correct the bug which is here, which makes me develop in a short time, and that's the philosophy about the DevOps that we will talk in other session, inshallah. And this is not like I will take the application and then I will move to Docker. No, there is a philosophy between developing on a virtual machine and developing on a container. Developing on a virtual machine, so let me delete everything. Developing on virtual machine, this is the same as developing like we did in the past. So what we do, I have a bug in my login.php. I will go to the machine, inside the machine, using SSH, for example, and then I go to the code, and then I correct the code, and then I rerun my server. This is like I go to my machine, I don't alter the whole machine. I only alter the single code I need. But in containers, this is not the same philosophy. What I do is I delete the old container and then I replace it. Of course, it's automatic. And I replace it with a new version. And this is what we call, let me write this in red. And this is what we call immutable or something like this, infrastructure. So if I Google this word and I run immutable infrastructure and I go to image, here is immutable infrastructure. As you can see, I had a version. Instead of correcting the same version, I'm deleting the old version and I'm going to the new version. So using containers, always think about versions. Don't think about correcting a code. You correct it in a place and then you upload the whole container. And in containers, they are not made, especially Docker. It's not made to run. Let me come here. Okay. So we said that infrastructure is something like this. You have container, 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 container. Containers, those containers, they are stateless. Now, what is stateless? What is stateful? In microservice, always think with the stateless philosophy. What does it mean? That means that if I have something, an operation that says +1, increment, and then I have here, for example, 2, 3, 10, 20. So stateless means that if I increment here, so let me choose another color. So let me use a red, for example. It becomes 3. This one becomes 4. This one becomes 12 and 21. And then if I come back and then I resend the same request, I will not find 3. It will go back to 2. So stateless, this is like a fish memory, fish, hoot. This is like a fish memory. It doesn't have a memory. It doesn't care about the past. Every time You give him something every time, they consider that's new. So this is a stateless. But a stateful, this is the machine where we increment, it becomes 3, 4, 11, 21. If we rerun the same function, it finds 3, so it becomes 4. Here it becomes 5. Here it becomes 12. Here 20. Here it becomes 22. So in microservice, we always think stateless. So if we want to make it stateful, then we need a database. So always think about database. Forget about using your disk. So your disk, it must use a temporary file. So that's why in Cloud Function, there is the folder /tmp. Next session, we will try this together. Well, tmp, you can write inside it, but outside this folder, you cannot write because we always think stateless. We don't think stateful. So if you need to migrate to microservice, first, you need to think stateless. Second, you need to think immutable infrastructure. Third, you need to understand that your container is not made to run a lot of time. It needs to get the request and then do stuff and then send it somewhere, which means that he is not made to run a lot of requests. And that's why we have the difference between LXC. So what I'm doing, okay. So we have LXC, LXD, and Docker. And here we are in the difference between those terms. Docker, when they started, they were relying on LXC. So LXC, this is Linux container. So in the past, LXC, it was like in 2008 or something like that. So Docker, they used LXC. But the philosophy behind LXC, this is like for making a container on an operating system level. And this is the same LXD. LXD, this is like an upgrade about LXC. By the way, this is maintained by the guys behind Ubuntu, Canonical. And Docker now, when we say Docker, we are not saying Docker. Yeah, of course, Docker, it was the first one who did that, but now Docker, it's different. So this is what I'm going to explain. So LXC and LXD, this is for sysadmins. This is oriented for system administrator. It's like provisioning. This is like, imagine it a virtual machine. This is a light virtual machine. But Docker, this is oriented for developers. And this is why every day you hear about Docker, because Docker developers use Docker, but system admins, they use LXC and LXD. So if you want to virtualize some machines with few resources, you use this as a sysadmin. But if you want to develop application and microservices, use Docker. So this one, this is made, for example, to manage the RAM for longer time, but this one, Docker, this is made to manage things in shorter time. And now let's have a brief history. So to have this history, let's go back to GitHub. In Google, they were using their own containers since long ago. So if you see these slides, of course, they are shared with the link. If you see this slide, it's like 2014. Yeah, 2014, where containers were not really a big trend. Yeah, at Google, they were using 2 billion containers by a week, which means that a lot of services inside Google, they use containers. So they were using their own technology, so they give it open source. And this is called LMCTFY, which means let me container this for you. And this is the technology, as you can see, that's an old repository that started everything. So LMCTFY, people come, open source, And they started developing something. So what Google do, they give a project, and then people start to developing, and there will be other technologies development from that technology. So lib container was developed by Docker. So Docker, they started with lib container, and as you can see, it's an archived repository. Why? It's archived because they migrated to what we call run C. Don't worry, I will explain what is run C. So after they did this, they come to run C. So what is run C? To understand this, let me close that and this and explain you this weird thing. But before I explain you this, I forgot something, which is important. Sorry. Now, I said, okay, I'm running my application on microservices, which means that this service, this service, this service, this service, and all are containers. We are not saying Docker, because there is not only one technology. The problem is that since they are communicating with the same kernel and everyone seeing its own namespace, if it crashes, no one cares. Those other containers, they don't know, which means that I need something to understand and to know if this crashes, I need him to go back. I need him to restart and to reload. To do this, inside Google, they were using what is called Borg. So what they did, they used the new technology based on Borg, and they gave it to the community, and this is what we have now named as Kubernetes. So Kubernetes, that's clear. If you want to find a job, go learn Kubernetes. Kubernetes, this is like the Linux of 2021. Everyone is migrating to Kubernetes because all infrastructure and enterprises, they are migrating to microservice because it costs less money. And of course, about security, I will explain the security in a few minutes. Can you please add 10 minutes or 15 minutes so I can finish this? So Kubernetes, this is the tool that manages those containers. And of course, there are other tools. So to manage this, so let me give you the drawing, of course, all the links. So what I do, I run Docker. So let me zoom again. I run Docker. For example, I have Docker. And then what I have the container D. The container D, this is like the daemon. This is like the program that makes me upload, download image, run them. Once I run in the, thank you. So what I have now, once I run my Docker, and I, for example, Docker run this command, let me use, Docker run. So what happens? It will communicate a service that is called container D. Once they run it, they need an OCI. So OCI, before I go back here, I need run C. So if I come here, where is that drawing? Okay, so run C is here. So let me draw that here. Okay, so when Docker runs those container, so run C is here. Run C, he is the one responsible on communicating between the kernel and the Docker, the container D. And this is the one who is responsible about the namespace. So how is the namespace programmed? This is using the run C. And so what I'm doing here, okay, let's go back here. So run C, this is the one which is responsible about isolating and asking for more resources and so on. And container D, this one, this is the one who is responsible about uploading and running and so on. And run C, this is the one, this is like the lower level, and this one, this is the higher level. And then here we have the container. So the one responsible about isolating the container, this is the run C, and the one who is responsible about running them, this is container D. And Kubernetes, before I talk about the Kubernetes, I said that Docker is not the only technology, which means that there will be other technologies that they try to implement their own way, and this can become a mess. So the internet or the cloud needed some authority that asked people respect this kind of protocol, and this is why the open container initiative exists. So if I come here, so let me hide this. So this is the OCI. OCI, this is like W3C. W3C for people who come from the web, the consortium. The equivalent on cloud, this is called Open Container Initiative. So every time you hear about the word OCI, that means that it respects that protocol. So in case in 5 years, maybe there will be no Docker, there will be another alternative, they need to respect the OCI to make your container work without breaking your nerves. So there are two things in the cloud. You have the OCI, and then you have the CNCF. So the CNCF, this is the Cloud Native Computing Foundation. So those one are taking application about cloud and incubating them. Once they incubate them, they make them graduated. So etcd, we'll explain that in a few minutes, Kubernetes, Helm, all those projects are now ready. And here is the container D. So container D, this is what Docker use. And the problem is that Docker with Kubernetes, Docker, as you read here, you will read a phrase here, the famous deprecation. So deprecation, this is something where we are going to abandon it. In reality, this is not Docker which is going to be abandoned. Let me explain this. Sorry. Oh, what is this mess? So you need to understand that to make Kubernetes run with Docker, because I said here, Kubernetes is the one responsible about running and stopping and knowing that something is wrong. So let me explain you this with other words. When I typed the command docker run, what I did, I am here, I run a Docker. So I'm a one-to-one. But the problem is that what if I have a lot of containers? That means I will not run Docker command. I will run something like Kubernetes. I will not complicate the example. I need something like Kubernetes. Now the command, we don't care about this. We will talk in other sessions. So to do this, I need something that do stuff for me. And those stuff, those are called CRI, for Container Runtime Interface. So Container Runtime Interface, Docker, when I use Kubernetes at Google Cloud, they use Container D. For Red Hat, they use CRI-O. So it's just a matter of choice. Both, they need to be OCI because they need to respect some specification, and then run C and make the isolation and so on, and then you will have your container ready. In other words, we have Kubernetes, we need the CRI. This is like a plugin. So let me draw something. This is like a plugin, the CRI, to make me talk with containerd or CRI or anything else. And since Docker was invented before Kubernetes, they used what we call Docker Shine. So when you hear Docker is deprecated, this is not the Docker itself. This is the Docker Shine. So to make Docker work with the old way, they needed what we call Docker Shine. So the deprecation here, this is not about the Docker, but this is about the Docker shine. And let me delete this. As you can see here, where I'm, so Docker shine. So this is what they deprecate and not the Docker itself. Now, don't need this. Yeah. Sorry, I will go to the upper page and rerun. Okay. Docker shine. So this is not the Docker that we deprecate. This is the Docker shine. Why? Because it doesn't have what we call a CRI. So the CRI, it's an old, the new way. Docker shine, this is the old way. Now, what is Docker? What is Kubernetes? Kubernetes, here is the Kubernetes. I will explain something like the easiest way. So in Kubernetes, we said that he is the responsible about running containers, but Kubernetes doesn't run directly the container. It has a special architecture. So what we have as architecture, I need a thinner one. So this architecture has two parts. We have a control plan and we have the execution plan. So this is the control plan and this is the execution plan. So the control plan, this is where we control everything. And the execution plan, this is where I am running my containers. So what does it contain? It contains the API server, which means that when I run my command on the server, for example, let's call it Kubernetes, which is not Kubernetes, which is kube control, but we will see that later in other session. I am interacting with the API server. So what does the API server? It communicates with a database. So let me zoom here. So I will communicate with the database, which is called etcd. etcd, if I come to CNCF, I will find it as a graduated project. So etcd, this is a database that is a NoSQL database, key value, that is responsible about storing the state of my architecture, what's going on now. So now the controller and scheduler, the controller, he is the one who runs those machines, and the scheduler, he is the one who is responsible where I'm going to run it, here or here. So now Kubernetes, what is his objective? I'm still in the control planner. We give him a YAML file, a configuration file, where we tell him this is the state I want to have. So Kubernetes, every time it checks the state, it tries to make it happen always. For example, I ask him, here I have 2 servers. Inside every server, I need 10 containers. So every time Kubernetes, he tries to guarantee that there is always 2 servers, and inside every server, there is always 10 containers. Now the containers, they don't communicate with Kubernetes directly because they are run in pods. So the pod, this is where we are running my container. And the pod, it can contain one container or many containers. It depends about our architecture. So let me check. Am I connected? Yeah, I'm still connected. It's fine. Yeah, sorry, because I fear to lose the connection. Huh? So now my container, I run it using the control plan. The control plan, if I have other machines that run in, I need to communicate with the pods. Now, how am I going to understand what's going on with the pods? Here I'm using this agent, which is called the kubelet. So the control plans communicate with the kubelet. Now, what is going on with the kubelet? The kubelet, this is the agent that tells the API server what's going on. And here, if I need something related to the networking, because I need the networking, here we use the kube proxy. So the architecture, we have the API server, we have the etcd database, key value, we have the controller and scheduler to be responsible where to run in and when to run them, and they communicate with the execution plan using the kubelet, and our container is inside pods. This is what we need to understand at the moment, and then we will do special sessions about this. Now, to end it, I said that run C is the responsible about running my container. And then I kept talking about security and all those bugs. So here is what Google did. So Google, I have my container, I have my kernel, and then I have my containers. I make it simple. I removed this layer. So I said that using the namespaces and C groups and all the other stuff, I'm separating. And this separation using run C. So Google, what they did, they created a new way using what we call gvisor. So gvisor, this is where we are running Cloud Functions and the new generation about App Engine. So they use gvisor. So gvisor, what is this philosophy behind? Let me go back to Docker security. This is the most important now. So as you can see, if you don't trust your Docker, you can go in problems. So you need, I associated with some links where you are going to search about best practices about containers. So this link, as you can see, a lot of people got some issues with containers. This link, this one is made to understand and to see the latest security problem. As you can see, this is a big security issue, and be careful. And what Google proposes when we upload, because we will see that in the practical way, it proposes in GCP a way to scan our container, because now in the past we have the viruses. I have a virus in my machine. Now we don't have a virus in the machine. We have a virus in our container. So this is the new way. If you want to do security, advanced security analysis, go and do Kubernetes or containers security. You will have a lot of money. So second one, if you have offline, you can use this one, Docker Bench Security. They are just tools, and all the links, I associated them. Claire, Dagba. And if you want some recommendation, you can use this link. And of course, all the links are shared. And here is gvisor. So gvisor, Google engineers, what they did this trick. I said earlier that to make this one, to make the user space communicate with the kernel space, they needed syscalls. So what the engineers did, they rewrote the syscalls. Not all of them, but some of them, which are the important one to run our containers. So if I come here, and then I go to the website, you can see that they reroute the syscalls to make them not attack the kernel. So when you run a container inside gvisor, you are not communicating with the operating system kernel. You are communicating with the gvisor reroute kernel. Of course, it's like you are using new namespaces where it's not risky for your containers. And there is a new way, which is the kata containers. So kata containers is, instead of running the containers, what they did as a solution, they say, okay, we are going to run a virtual machine, a light virtual machine, for example, using QEMU. And then inside every virtual machine, light virtual machine, for example, I'm going to run inside it a container, so it doesn't escape. So this is the way how Kata containers are using. So this is gvisor, Kata containers, and then this is like the Amazon Firecracker. Why I'm talking about Firecracker? This is the way they execute on Lambda, the function as a service about Amazon. But in reality, Amazon, they used cross VM, which Google developed. So Google developed this for Chromium OS, and if you go to Firecracker, and you will see here, Firecracker started from Chromium OS. So they do the same thing that Kata, they run a small virtual machine, a light virtual machine, and inside it, they run the container. So Firecracker is based on something Google invented. So, and there are other articles about sandboxing, because sandboxing, this is this practice. This is to put something inside the box. So that's what we call sandboxing, to isolate it and not make it go outside. So I think I talked about everything. So the main idea, don't worry about containers, and unless you are exposing them to someone. Here, you need to understand the risk. But if you are in a public provider, for example, like GCP, they have their ways to isolate them and to make them more secure, for example, using gvisor. Now, let me at the end check about, as you can see, we didn't do a lot of stuff on GCP. This is for next time. So let me check about questions. And I'm sorry to make it complicated. So let me go for questions. So, do you have any questions? Do you have any questions? So of course there will be second session and third session, and where we will go deeper until you understand the concept of Cloud Run. So do we have some questions? Yeah, thank you, Omar Ibrahim. Omar Ibrahim is a follower from the beginning of our session, so thank you very much. So, of course, there are other sessions about Docker and about Kubernetes in the playlist. You can have them, you can recheck them, they are recorded, and then we will do other sessions in future. So if you don't have question, thank you very much and stay safe and see you soon, inshallah.